Hey all, welcome to another session with me, Varun at OdinSchool. And in this session, let us understand what is deep learning with TensorFlow. And that would be TensorFlow 2.0. That would be something different that we'll be watching in this session. And also in this course or in this tenure, let's understand what is the importance of TensorFlow and why do we have to learn it. Would learning TensorFlow bring about any difference in the way we are right now, or would it upskill us, or would it get us into a better platform, or what is it that we would be working on if in case we get equipped with TensorFlow. And at OdinSchool, we basically try to upskill a candidate, be it a fresher or be it a fresher who's planning to learn a new technology, or be it an experienced person who is trying to upskill. We believe that the more you stay skilled, the more you stay ahead. And talking about me, my name is Varun, as you all know, and I have an experience of 7 years working as a developer and a trainer. And over these years, I've gained knowledge on languages like HTML, CSS3, JavaScript, R language, Python, machine learning, basics of deep learning, etc. And as we all know, there are a group or set of languages which are front end. You have almost all these languages which are front end based languages, like you have HTML, CSS, JavaScript. All these are front end languages. And then you have R language, you have Python, you have machine learning, which I've used for data science. So yes guys, this is how my tenure is split into different years. Okay, now notwithstanding this, I would also request you all that if you find the video useful and if you feel that any of your friends might also be able to view this and gain some understanding out of this, do hit the share button, hit the like button, and also do subscribe to this video for regular updates. This channel has a lot in it that is yet to be exchanged. Now, talking about the agenda, it would be to understand what is TensorFlow 2.0 in the first place, what are the different types of neural networks available, and we would be looking at some basics of TensorFlow using Python as a platform. Now guys, when we talk about TensorFlow, that is, what does it do and what are the capabilities of this beautiful language, or this a lot of people call it as a language, but I would call it as a library. Now, talking about the different qualities we have, it is easy, it is powerful, and it is highly scalable. Now, talking about easy, as we all know, we know that it's got some really simple APIs. Right guys, the APIs, the application programming interfaces, are really simple. They are focused on Keras, which is another library for deep learning, and eager execution. Now when we talk about TensorFlow 2.0, TensorFlow 2.0 is actually advanced as compared to TensorFlow 1, which was initially what we had on our systems. Because TensorFlow 2.0 has made the code easy. Okay, this is advanced than TensorFlow 1.0. It has made it easy, it's made it powerful, and it's made it scalable. And notwithstanding this, there are also a lot of other things which we might not know. For example, you do not have sessions anymore. Okay, when we talk about TF1, we had something called as sessions. Now this session is not anymore required in TensorFlow 2.0. We all know that TensorFlow 2.0 makes things easy for us. It really has very smooth APIs, and notwithstanding this, it's really flexible, and I think it's actually designed to make this language more powerful and more efficient. Right, and it also has an edge because it believes in lesser coding, it believes in eager execution. It does not believe in a complete unfolded kind of an execution, not after TensorFlow 2.0. And also when we say scalable, it is tested at Google scale and it can be deployed almost anywhere. Any platform wherein you can say that you have active internet connection and that you have a good above average system that you're using, I think you should be able to use TensorFlow 2.0 very comfortably. Now as you can see, this is how TensorFlow is basically built. Here I have a set of 3 to 4 diagrams, as you can see. Now all these diagrams represent different kinds of networks. TensorFlow or even TensorFlow 1.0 or 2.0, it is basically built on the concepts of neural networks. Now, when we talk about neural networks, the basic idea of neural networks is to imitate our intelligence. Okay, now when I say us, it is basically trying to imitate our intelligence. But then here the question is, do you really think the intelligence which we have gained over centuries, any system would be able to just get that in 2 to 5 years? That's not possible. So that is why we notice that there has been an improvement, or that there has been a change, or that there has been a development over how we have slowly seen a growth in the types of neural networks. So first we have a single layer perceptron, then it is a radial bias network. Now this is a multi-layer perceptron. Now basically, or I would say ideally, this is how your deep learning structure looks like. Now this here is my input. These two layers are the logic execution layers, and this layer is my output. So you have 1, you have 2, and you have 3. So this is how my 3 layers are completely divided and spread out into. Now, notwithstanding these 3 layers, if we go forward, you have recurrent neural network. So here you can see in recurrent neural network, I have my input, then I have my overshadowed execution layers, and then I have my output. This is LSTM recurrent neural network. We will look about all of these in the next slide. Then you have Hopfield network. Here you can see it's completely a set of radial and then interconnected networks. It's completely interconnected. And then you finally have Boltzmann machine. Now here in Boltzmann machine, you can see half of it is probabilistic hidden unit. I mean, this part is probabilistic hidden unit, and this part is backed input unit. And when we talk about the Hopfield network, they're completely filled with backed unit. Okay, now here when you talk about the LSTM recurrent, or probably when you talk about the LSTM recurrent, here you have feedback with memory unit. So guys, there are different kinds of processes and different kinds of network establishments that we have for different requirements. Not all the requirements that we work on can be solved using the same kind of network. Now, without wasting any time, let us quickly understand why do we need each of these networks for. Now, to begin with, as we all know, the first one that we have is RNTN. That is recursive neural tensor network. Now, just to give you a very minor understanding, or just to give you an overall view, they are extremely useful for text processing. Right, so here I have RNTN, that is what we were talking about. So here the first one that I would want to talk to you about is RNTN recurrent neural network, which has text processing capability. Now when we talk about text processing as a capability, here we would be trying to work on different text for NLP, and NLP is just one of the uses. Okay guys, when we talk about RNTN, they have a tree-like structure, okay, wherein they have a neural net at each node. Now we can also use RNTN for boundary segmentation. Boundary segmentation is another use case of RNTN. Okay, notwithstanding boundary segmentation here, which we were talking about, word vectors are also used as features, and they serve as the basis of this classification. So here you have something called as word vectors, wherein you have a library called word2vec, WORD2VEC. I think that library would give you a lot of commonalities and shared functionalities. Then after we have taken the sequential classification, they are then grouped into phrases and subphrases, and they are combined into sentences, and then we later calculate the matrix of these. The first step towards building any RNTN is word vectorization. So guys, word vectorization becomes very, very important in this vectorization. Here, this concept becomes very important when you're talking about RNTN, because without word vectorization, there is no point in going forward. And what does word vectorization do? It basically converts a corpus of words into vectors, which can be then thrown into vector space, and they could be, they could be measured using the cosine distance between them. And it is also a separate pipeline from NLP. It creates a lookup table that will supply word vectors once you're processing sentences. Now after this, you have something called as NLP. NLP will then take in these sentences, tokenize them, and then tag them into parts of speech. That is, POS tagging happens later. So to organize sentences, recursive neural tensor networks, they basically use constituency phrasing, which groups words into larger subphrases. Alright guys, for example, you have noun phrase, you have verb phrase, which are some POS tagging. Now this process relies completely on ML, that is machine learning, and it also allows for additional linguistic observations to be made through these words and phrases. So finally, these word vectors can be taken from W2Vec or Word2Vec library, and they are substituted for the words in your tree. After they are done, you would have an understanding about how these words are divided and what it does for us. Right guys, so that is a basic understanding of RNTN. Then the next one that you have is deep belief network. This is the second one that we would be talking about, and this is very highly useful for image recognition. Now when we talk about deep belief network, the first one that I want you to understand about, let us firstly clear the screen. We have a lot of information here. Alright, so now talking about DBN, which is deep belief network here. Alright, neat enough. Now this is an unsupervised probabilistic deep learning algorithm. Okay, we'll just keep this as simple as it is sounding, and here it has multiple layers. This is obviously understood. Okay, it has multiple layers, and also the variables are generally binary. Okay, we have binary variables, and they are also called as feature detectors. They basically detect features. Okay, now talking about DBN, it is basically a hybrid graph model. There are two layers which are undirected, and lower layers have directed connections from the layers above. Now, what do we mean by this? It basically means, in very simple words, that it is a stack of restricted Boltzmann machine or autoencoders. Now you have two layers of DBN which are undirected, and you have symmetric connection that's between them, which forms an associative memory. Now the connections between them, or the connections between all the lower layers, unlike the layers above, which are undirected, the connections in the lower layers are all directed. Now lower layers have a cyclic connection that convert associative memory to observed variables. The lowest layers or the visible units receive input data, and the input can mostly be binary. Now guys, here when you talk about it, there are no interlayer connections like RBM here. And also, hidden units represent features that capture the correlation. So basically, these hidden layers, they are trying to capture the correlation between your data. Every unit in each layer is also connected to another unit in neighboring layer. So this is how a DBN basically works. Now, when we talk about DBN, it basically trains itself using the greedy learning algorithm. And when you talk about the greedy learning algorithm, it uses layer by layer approach for learning the top to down generative weights. These generative weights, they tell you the more you have weight, or the more you have generative weight, the more one layer depends on another. So here we run several steps of a variant of sampling, which is called as Gibbs sampling, on these two hidden layers, and this stage is essentially drawing a sample from RBM. We then use another pass of sampling through the rest of the model to come up with a layer of visible units. Alright, now guys, when we talk about what is greedy layer learning or greedy learning, it is a training algorithm wherein we train DBN one layer at a time. Now whenever we refer to the word greedy learning, guys, greedy learning is basically you training one layer at a time. You here cannot train all of them in one go. That is something that's not possible. So easy way to learn anything complex is basically to divide it into smaller groups. It's basically to break it into easier sections. And when you do that, that is when you would be able to understand what is greedy learning. And greedy learning only makes easier for your system to understand the data. Alright, and as I said, the idea is to give a sequential learning so that you are able to receive different representations of the same data. All these factors or all these reasons contribute to your greedy learning. Now, after your greedy learning is done, then you have a lot of other phases that your system would still have to go through, and finally, as you keep adding another RBM, as you keep adding a lot of calculations, lot of Gibbs sampling and a lot of other sampling, then your training is done. Then you fine tune it for your feature detectors. Then after fine tuning is achieved, probably by using wake sleep algorithm or back propagation, then we can say that we would finally be able to use DBN. Now after DBN, the next one that I have for you is RNTN. Now let us also talk about what RNTN is. RNTN is recurrent neural networks. Now there are a lot of variants of basic recurrent neural networks, guys. And now when we talk about basic recurrent neural networks, let us understand what they do. Now when we talk about the RNTN, that is the recurrent neural network, this is a very special one. And why is it special, or what makes it special, is something that we would want to understand. Now an RNN, or probably an RNTN, a recurrent neural network, it remembers each, now this is what we're talking about, guys, a recurrent convolutional neural network, which is generally used for object recognition. Alright, now these recurrent neural networks are even used with convolutional layers to extend the effective pixel neighborhood. Alright, now this is one of a very important use, and notwithstanding that, what makes it special is it remembers each and every information throughout time. It is useful in time series predictions only because of the feature to remember previous inputs as well. This makes it one very important feature. Now, this feature of recurrent neural networks is called as LSTM, that is long short term memory. LSTM is one very important feature of the same. Now, how many types of neural networks do we have, guys? In total, there are 7 types of these kinds of neural networks that we could use. The first one is multi-layer perceptron. The next one is CNN, that is convolutional neural network. The next one is an RNN, that is a recursive neural network. Then we have another variant of RNN, that is recurrent neural network. Then we have LSTM, that is long short term memory. Then you have STSM, that is sequence to sequence models. And then we have SNN, that is, I guess, it is shallow neural networks. So with all these kinds of different varieties, it would become very important and very tricky for us to choose which neural network to be used when and where. Now here also there is a very big confusion between CNN and RNN. Guys, it is also to let you know that CNN is at any given point of time more powerful than RNN. Okay, so that is why we would want to use okay, now even before understanding why we would want to use this or why we would want to use that, RNN includes less feature compatibility when compared to CNN. This network takes fixed sized inputs and also generates fixed sized outputs. RNN can also handle arbitrary input and output length. Now it's all these features which makes it special. And not just withstanding time series prediction, which we were talking about for RNT and convolutional network, it can also be used for some other great applications like image captioning, Google autocomplete features, etc. Right, guys? And also, when you talk about CNN, which is a convolutional neural network, the training time is significantly smaller here. And it is natural for me to think that CNN is faster than RNN because it does not build a relationship between hidden vectors of each time steps. So it takes less time to have a forward feed and a back propagate. Now these are some of the reasons essentially because of which convolutional network is much preferred and much used and is much faster than RNN. Then finally you have your recurrent network. Now, when you talk about your recurrent network, even recurrent network does not go away without any advantages or any disadvantages. Alright guys, now here when you talk about recurrent network, it is used for speech recognition, right? And also, now let us understand what is recurrent neural network basically used for. Now when we talk about RNN, it can also be used for NLP, by the way. Okay, now this is the focus of the area of focus right now is to understand the speech recognition or what can recurrent net be used for. So as we've just understood, it can be used for speech recognition or it also can be used for NLP and other characteristics or other projects. Now, how do recurrent neural networks basically work? To train an RNN, we use the application of back propagation. Okay, now this back propagation is used through time. Now this is how back propagation works. The gradient values will exponentially shrink as it propagates through each time once and again. And again the gradient is used to make adjustments in the neural network weights, thus allowing it to learn. Now this is how recurrent nets generally work. Now these variants or recurrent nets also do not go away without types. Yes, there are different types of recurrent networks that we might have to touch base upon. The first one of all of these being binary. We have the second one to be linear. Then you have the third one to be continuous. You have additive. Then we have shunting. So guys, there are a lot of variants and it is not over. You still have other variants like you have habituative transmitter gates, you have gated steeped descent learning. So guys, we don't want to get into all that right now, but these are the different types of recurrent neural networks you should know. Again, RNN is a very popular deep learning algorithm which is used to carry out a number of tasks, again, which can be used for Google autocomplete or image captioning. Now, an RNN remembers each and every information through time and is also useful in time series prediction, which is the reason why it is also called as long short term memory. Right, guys? Now, as I said, there is a huge difference between CNN and RNN, and it would require good amount of understanding for us to know how we could work on each of these models. Okay, so in short, RNN came into existence which basically showed us how the issue of hidden layers can be solved. in traditional neural networks, all input and output layers are independent of each other. But in cases like when it is required to predict the next word of a sentence, the previous words are required, and thus these previous words which are required, they require this importance of using RNN, that is recurrent neural network. So guys, I hope you have understood what are the different types of networks we have, and how using each of them or using any of them in case or in fact would bring about a difference in us. Now let us take a quick comparison at each of these, that is the different libraries that we have available in with us, and what is it that they would help us with. Now when we talk about the different libraries here, that is what is TensorFlow 2.0, and also what are the changes that we have, and what is Keras and what is PyTorch. Guys, all of these, they are different and are also used for different purposes. So the first library that you have here is Keras, the second one is TensorFlow, and the third one is PyTorch. Now when you talk about Keras as a library, as you can see, it is an open source neural network library, guys, and it is capable of running on top of TF. Okay, so here that word becomes pretty important, on top of TF, which is a library. Alright, now when you talk of TensorFlow, it is an open source library for data flow programming, and also a math library that is used for machine learning algorithms. Alright, now when you talk about machine learning algorithms, it's not necessary that all these machine learning algorithms are only basic. It can get executed from basic to intermittent to advanced models. So your TensorFlow's got good capacity to handle deep learning problems of all of these levels, or of all of these types, or of all of these sources, what you can say. Now the next one, after which we have PyTorch. PyTorch is also, please pay attention, is an open source ML library. Okay, now when we say open source, what do we mean by it, guys? Open source basically means you could be using them for free of cost. Okay, and they are downloadable from Google also. And PyTorch is based on Torch as a language. Torch is a language, or Torch is another tool that we all might have heard of. And it is used for apps like NLP. NLP is natural language processing. It is used by FB's AI research group, that is FB's artificial intelligence research group. So these are the different libraries that we have available for use of deep learning. And this, what we have seen here, is just a quick introduction or a quick understanding of each of them. Now in the next slide we would be talking about of what is TensorFlow 2.0. The first thing that we would, or the most important thing that we would have to know here, is multiple changes have been made to TensorFlow 2.0 to make it more productive. And what does it do to us? It would eliminate redundant APIs. That is, there are no longer any application programming interfaces which are very lengthy and which are only taking more time to come out with an output. They make your code more consistent, that is, you have unified RNNs, unified optimizers, etc., and it better integrates with Python runtime and also with eager execution. We now have a very good understanding about what is Python runtime and also what is eager execution. Now, without wasting any time, let us quickly move on to the Anaconda platform, wherein we would now try to understand what is TensorFlow library. Now guys, this, as you're able to see, is my Anaconda platform, this beautiful interface here. I have written some lines for you for us to just take a check upon. So we will now be working on each of them to understand what it does. Now for all those of you who've been working on TensorFlow and who do not have the latest version of TensorFlow, guys, this is how you do it. You have to go to Anaconda prompt, or you can go to Conda prompt, and when you go to Conda prompt, you would be having a Conda create new TensorFlow TF, new environment TF with the name TensorFlow. Now once this is created or once this is done, you would be able to check the version of your TensorFlow after you have installed the libraries, you have imported the libraries as TF. You would be able to check the version. The version has to be 2.1.0 or anything above 2.0. This is how you would know that you're working on TensorFlow 2.0. Now, as I said, TensorFlow 2.0 has got some updated libraries. You do not have the requirement of creating new sessions or placeholders, and all those have been eliminated. It becomes very easy for us to now code and to understand what this is or what this does. Well guys, now here what I'm doing is, whenever you would want to work on TensorFlow, as we all know, TensorFlow, when you want to work on these, you would have to create a constant. You would have to create a tensor. Now what is a tensor and how would your tensor be created? So as you can see, I'm taking a tf.constant, wherein constant is a value. Now as you can see, I've taken this is a value here and I'm passing it to be the type of value. Now when you see the type of value, it would automatically give you a TensorFlow Python framework, and it's an eager tensor. So we are able to see that it is executing eager coding or easier coding, and this is how you would have an output when you check the type of value. But when you want to print your output of only the value and nothing else, that is when you would be using tf print of value. A bit of difference here, you have the type, this is an eager tensor type and this is the value, and when you check the value, this is my output, wherein it is giving me the same value which I have printed here. Now just like how I've taken a value, I'm also taking a value 2, alright, within another function, within another constant, and I'm saving it into value 1. And you can see I have value 2 in my output. Now what I would want to do is, I would want to print an output of value 1 and value 2. And it's very easy guys. In order to do that, I would be going into, or I would be using value plus value 1, storing them into final, which is the desired output variable that we will be checking out now. And I would be using tf.print final. It is this variable that I would be printing, and here you see I have value plus value 1. Again, no session needed. Likewise, we could also check things for your mathematical operations, and when you check things for mathematical operations, you can see I have two numbers that I've taken, 15 and 12, and now I would want to perform basic mathematical functions on these. So here I'm taking a tf.constant with a value of 15 and with a value of 12. Alright, and now when I add them, you can see I have a value of 27. Now guys, it's also very imperative for us to know that when you add these values, that is when you have an output of 27, here NumPy is already coming into existence directly. I do not have to involve it, or I don't have to do anything to ensure that it is out. It comes out naturally by virtue of using TensorFlow. Alright, now here in the next step I am also printing my output, that is only a 27, and as you can see I have my output also. And not to get that, all that I would have to do is take in tf.print. So whenever you want an output in base format, or whenever you want an output and not the whole explanation, not the whole reasoning behind it, or not the whole data type, shape and tensor, you don't want all that, in that case you would have to use a tf.print and not just the variable allocation. going forward. The next one that I have for you is how to create a matrix tensor. So here, as you can see, I'm taking tf.fill and I am filling them with all fives. I want a 5 by 5 matrix. As you can see, I have 1, 2, 3, 4, 5. I have 5 rows and 1, 2, 3, 4, 5. I have 5 columns. So you can see I have a 5 by 5 matrix all filled with 5s. And it is the same fill function which we use even in Python, basic Python or core Python. So we are using tf.fill, filling them all with 5, and now when I do matrix.numpy, you would see I have an output here. This is my output. Now if I want to get the shape, all I would have to do is matrix.getShape, and it would now throw me a shape of tensor shape 5, 5, which means that my data is arranged in a 5 by 5 matrix. So that is also pretty straightforward and there is nothing so complex to understand. So guys, I'm hoping that all that we're discussing here is going through pretty easily and there's nothing so confusing here for us to get really worried about. The next one that I have for you is to check if you have easy execution, that is eager execution or not. As I said, eager execution is a feature that we have added onto TensorFlow 2.0 and it's coming off late. So here I have a small logic, that is, if your condition is getting executed, I want it to print that it is enabled, else it will give me an output that it is not. And what is it? It is eager execution. So you can see that in my TensorFlow I have my eagerly executing functionality which is enabled. So yes, you don't have anything to get worried about it. Also, there is a way wherein you could shut down or wherein you could manually turn it off. We'll see how to do that in the entire course once you subscribe for it. Then you have checking for TF1s and TF0s. That is, you want to fill all the board or you want to fill your entire matrix with 1s or 0s. That is when you would be using them respectively. So here I am taking all 0s and I am taking my functionality to be tf.zeros. So I would be having all the values in it and I am giving it a shape of 2 by 2. So I want my matrix to be in a 2 by 2 shaped vector or in a 2 by 2 shaped matrix, and here you can see you have your tensor which is in a 2 by 2 matrix shape having all zeros. And why are we having all zeros? It is because of this functionality, that is tf.zeros. And just like tf.zeros, the next function that I have for you is tf.ones. And here when I do tf.ones with a value of float this time or with a data type to be float this time, you would see that in your output you have 1 point towards all the ones. The shape is 2 by 2 and the data type is float. Likewise, let us also understand what is transpose of a matrix or transpose of a tensor. We all must have had good idea about what is a tensor or what is a transpose of a matrix or what is transpose of a tensor. This is something that we all must have seen in our lower school. So here you have x is equal to tf tensorflow dot constant. So I'm taking a set of rows and columns. So this is in the form of 2, 3 or 2 by 3 right now, and I'm transposing the vector and I'm transposing it to x, and when I do transpose, it is now converting it into 3 by 2. It's 3 rows and 2 columns. It's pretty easy guys, pretty straight, and there's nothing complex for you to get confused here once again. The next one we could do is to multiply a matrix. Now, when you're multiplying a matrix, it's very important for us to remember the number of rows and columns. You cannot have 3 rows 2 columns, or one multiplied with just 1 row and 2 columns, or 2 rows and 1 column. The number within the matrix that you're adding also should make sense. So now here I'm taking a constant of 1, 2, 4, 5 in x, and I'm taking another constant of y which has only 2 rows and 1 column, that is 1, 4. Now I'm using this functionality, that is matmul or matmul, a lot of people refer to it, and this would do matrix multiplication for me, and here I have my output. Alright guys, and here I have 9 and here I have 24. So the shape, as you can see, is 2 rows and 1 column, and the int type is, the data type is int32. Just like how we have checked for matrix multiplication, we can also check for simple multiply. And when you do a simple multiply, you would be having an element wise multiplication, guys. That is, here when you multiply x with y, you can see you would have 1 into 1, which is 1, 1 into 2, which is 2, 4 into 1, which is 4 into 4, which is 16, 5 into 4, which is 20. So I have my 2 by 2 shape. And then in my next set of operations, I'm considering the rows and columns, guys. So I just want to see how many rows and columns that I have within my shape, and that also is doable. So I'm taking rows comma columns, and I'm feeding this to x shape. And in my print, I'm taking a fields and giving my rows and columns, and it has 2 rows and 2 columns. So that calculation is also possible. The next, I'm taking a variable of 0, and I'm adding 1 to it in B, and you can see in my output I have a value of 1 printed here, and the int type is, the data type is int32. It's very simple, guys. So every time you do not actually have to consider B, then again consider TF variable, pass this into that, then execute it. All this is not required. In eager execution, you have lot of codes which are now made pretty easy. There are a lot of things that are yet pending for us to understand about TensorFlow 2.0, but what we are looking at right now are the most important and foundational concepts. Then I would want to assign my A with a value of 2 instead of 0, and in order to do that, I am assigning 2 to A, and it's a numpy operation. And now if you can print your A as an output, you would see, oops, now this output is because we've not executed things from the beginning. Alright guys, so we could also choose to do that. That's not a problem at all. It's just that would take us some time. Okay, we'll go to the next command by the time we have the output here. And the last one that I would want to do is I would want to define the addition of A comma B. Now here when I'm taking addition is a function that I'm creating that could be used anywhere else for your perusal. Right, now here when I take an addition A comma B, I'm returning a logic of A plus B. Now here even if I write addition and I probably type in A into B, you would notice that the result would be modified as A into B. So I am using addition, which is this, and when I use addition, this logic would get executed for A, B, which is the reason why I have an output of 30. Now let us just check if this line is executed, guys. I think now we can now start executing the lines below. That is okay. So you can see, then I'm taking my constant. So all of these need to be changed and checked. Alright guys, so this is how you can see each and every time you are working on something, you would be having values changed and you would be having things getting executed. Now here A is not getting defined because all of these, my line number 1 after line number 44, all of these are in a set of connection. Right guys, so that is the reason why you would have to execute each and everything each and every time before you make a step. And also here you can see that after importing my TensorFlow, you can see that this is getting executed as 1.14. That is because in your Anaconda navigator you have environment, and when you check your environment you would be having multiple environments that you have created. Now this is a different environment that I'm executing for you to see that you might be having different environments in your Anaconda navigator. So whenever you're working on Anaconda navigator for TensorFlow 2, it is very important for us to ensure that all the versions are updated, failing to which you might have inconsistencies. Right guys? So now going on to the next slide. So to give you an idea about the summary of major changes that you might have experienced just now, old libraries have been cleaned up. There are no older libraries which are required anymore. You have eager execution, which is a very big add-on for all us developers. There are no more globals that are used. You have functions and not sessions that are used. You have model building and deploying that is made very easy. Right guys, so these are a summary of the different changes that have been brought onto TensorFlow 2.0. So guys, I hope you have understood what is TensorFlow 2.0, how it is useful for us, how it is useful for you, what are the different types of neural networks that have come in, and how different types of neural networks can help us solving different problems. And also, most importantly, what is TensorFlow 2.0 and how do we start working on it on Anaconda navigator using Python. So I hope you understood all of these, and if in case you understood and if you really like the videos guys, do not forget to hit the like button right at the bottom of the video, and also subscribe to our channel for regular updates, and for notifications you have the bell icon right next to it. And if there's any queries you have, literally any queries with regards to TensorFlow or data science or anything that you might want to ask regarding your career, you have the comment section right below. Thanks a lot for watching and for your patience. I hope you have enjoyed watching the video. This is me, Varun Rao, your mentor, signing off. Have a great day and all the very best for the interview or for the job role that you're about to take up.